introduces you to creating classes and objects. You already know this. What else does it introduce you to? Encapsulation. Do you all know what this pattern is? It's like when you have something to hide, you encapsulate. And we all have something to hide, right? Like our thoughts. We want our social security numbers to be hidden. We want our credit card numbers to be hidden. Right? We all have to encapsulate. How do you implement this? Private. When something is private, it's encapsulated. Okay? Then there is containment. When an object is instantiated inside another object. Yes? Like coffee is contained in the cup, and when I put a lid on it, coffee becomes a private variable. But then I can write a public method, drink coffee, and then there is a lid object, and there's a little hole in the lid that I can drink the coffee, right? So every time I call the drink method, the milliliters of coffee in the cup reduce, right? It's all, this is about objects also, and object interactions, okay? So you're going to be applying containment, and then, of course, my favorite is file IO. You have to read a file and tokenize and build an array of objects which contains an array of primitives. So the bug we had vis-a-vis this point was fixed and posted, right? I figured out the fix like later that evening, I think. I had an aha moment. And I told you what the fix was too. You guys got that? You all understood that, right? I didn't say that loud. So these are the three concepts, right? Now, if you have this complaint that, you know what, I didn't write the file IO code, so I don't get it. Fine. Here's what I suggest based on conversation with actually a few of you. You're saying, I don't get it. You know, file IO, yeah, you wrote the code, I don't get it. We have it on video. So we'll post it, I'll post the video so you can watch the 2-hour kind of action in slow motion on how the code came together, right? But there is also some good coding techniques. This is a point I'll want to talk about later. This part, I don't care if you get it or not for submitting the lab assignment, because I'm giving you the code, it works, it's not buggy, you know, use it. Build the rest of the lab, be done with it. And one fine morning or afternoon, whenever you feel fresh, sit down with a fresh mind, sit down with this code and read it. So reading the code means go through it line by line, do a logical flow diagram. You know what logical flow diagrams are? You draw boxes and lines, right? Boxes indicate actions, right? Lines indicate which action happens next. And then when you have a decision to make, you draw a rhombus. And then you can say if it's true or false, right? If you don't know what logical flow is, Google it and you'll see a bunch of diagrams. It's not hard, right? Point is, go through the code in slow motion. Spend an hour, read the line, draw the diagram. Read the line, draw the diagram. You get confused about it, right? Show up with the diagram and let me explain, right? And I'll spend time on that, maybe in class, and maybe we'll do it together. Or if it's one-on-one. As long as you invest that time and you come up with very pointed questions, I'll make time for each one of you. If you can't make it during office hours, let's set up a time. We'll do a Google Hangout. You know, we can talk online. It's not like, you know, you have to be present face to face, right? And these questions only take 10-15 minutes. It's not like we need hours and hours. Okay? But make sure that you understand the code that was written, because you got to make it better. The only way to make something better is to understand what's wrong with what I've done. And there are a lot of things that are wrong. It works, right? Because it was done quickly, so it works, but it can be made better. So take this as a task that'll cost you an hour to 2 hours of focus time. I'm not talking about drawing a logical flow diagram in front of TV with a beer. Not gonna happen. Yeah, it's not gonna come together. Focused, right? All right. Then we have coding techniques that you learned, and I'm talking more about things like, hey, you know, debug was a pretty cool thing, no? Have you tried changing it to true and false? And all of a sudden we can spit out all these system.outs or turn them off. Now, okay, you guys wanted me to cover the fix, so let me do this. I have actually I fixed it in the lab, so I have the copy I uploaded on Piazza. Okay? Please, I hope you guys are using the copy that's on Piazza. So great, here it is actually. And the problem was with the value of the counter. So here we have file name is null. We open the file this is to refresh your memory. We open the file, we read a line, right? And we're gonna do something with that line. If it's line number 1, I say I want 6 stores, I make 6 stores. Then I read a header, I ignore it. Then I read a full line, then I want to build an object using that line, right? That was basically what this if statement is. If line is null, end of file is true, get out. If not, then print the line that I just read. Then if the counter is 1, right? The first line, I've got number of franchises. Make 6 stores in a franchise for me. And then tell me you did, right? If the counter is the second line, let's just ignore it. This is like the first coolest statement where you say, if I had $1 billion, and then the rest of the word is waiting, okay, and you say semicolon. Right? So that's what we are doing. Now if the counter is greater than 2, lines 3 to 8, then take the line and build a store, right? And my problem was, the fix was in this guy right here, counter minus 3. See, because when I say counter is 3, and I pass that to the build store function, right? It was taking the counter as 3 and it was allocating the store to the third franchise location. Where do we do that? We take the counter, right? See, I was saying counter set store. So instead of setting it to the 0th store, I was setting it to the 3rd store. You get it? So that's why I said, oh gee, I should just subtract 3, then I'll set it to 0th, And the moment I did that, life was perfect. That was the fix. Does that make sense? Yes?
Why does build store have to return the week?
Louder.
Why does build store have to return weeks?
Oh, because I wanted to. It's more to verify that my line is intact with 35 values, right? So, because sometimes, I mean, in the near future, you're gonna have to deal with jagged arrays. So, in one line I get 35, in another I give you 38, in another I give you 31, right? I mean, life is not perfect because you get the number of values you get in a line can vary, right? And it's not like we have to learn how to deal with that in our software, right? So this is a starting point that at least I got 5 stores. If I didn't get 5 stores, now I need to do something. If I didn't get 7 values, 1 for each week, I need to do something. So later on in the game, I'm also going to write a separate method when I'm tokenizing all the weeks, right? And if you give me 5 days, I'll say, hey, what's going on? What about the last 2 days, right? So these kind of problems, when they occur in software, they are called exceptions. And I think we did talk about exceptions because these are problems that you can recover from, right? Software doesn't have to be, I can put in 0 value and I can write a report saying values for Saturday and Sunday were missing. So the numbers might be off base, but at least I've done the computation, right? It's about healing the software. That's another pattern you guys are going to learn in this course, or at least the starting point of. How do you create software that can find issues and fix itself? See, that's a cool software. Like Gmail is a really cool piece of software. It fixes itself. Well, if you're saying, well, I never noticed, well, try. Go and disable your network card. What happens? Your chat fails. And it says, I'll try in 10 seconds, in 15, in 20. And then it gets tired of you not having a network connection. It says, I'll try in 5 minutes, in 20 minutes, in 5 days. But it says, I will heal. And then you say, heck with you, I'll just close you. Right? So it never heals. But if you bring the network connection back, it retries, it comes back. Self-healing. You can still read your email messages. It's not like when you have 50 messages in your inbox, if you click on it while the network card is out, you can look at the details. You may not be able to get the attachment because that requires a network connection, right? So, another example of self-healing. So the point is that when we make products, it can continue to operate up to a certain extent if the physical environment in which these products live fails. Same thing with mobile devices too. Mobile devices, network connection is gone on and off. So when you write Android applications, you have to be smart about these things. Okay? So please draw a logical flow diagram for this. For understanding this, if you understand it already, life is good. Then go write franchise and store classes. Write a nice driver, right? To test and print the data. In fact, you should really have one. Let's see how you do in user friendliness. I'll leave that to you guys. You have to figure that out. All right? Any questions? Assignment 3. And this is due when? Soon. Oh, got plenty of time. All the main part is done, right? all you have to do is write like 6 functions and a driver. How hard can that be? You guys will do just fine. Okay. So, object relationships. We know encapsulation. We know containment. And we also know association. If you pass 4 instances of an object, okay, so we are talking about object relationships, and I guess we are not talking about object relationships. Okay, so in object relationships, we have covered these 3 already. Encapsulation, containment, and association. We have seen examples from the physical world, plenty of them, so you have an idea of how these 3 work. And there are 2 more to be added to your vocabulary. We will add inheritance today. Inheritance is a relationship where we set up a concept of a parent and a child. So inheritance is between classes, not objects. Inheritance is set up between classes, and objects are the beneficiary of inheritance. So the parent class can have properties and methods. And at this time, I'm only interested in instance variables and methods. I'm not interested in anything else. Then we have a child that extends parent, right? And it automatically, without doing anything, gets the properties and methods of the parent class. So now what happens is, child wants to do things on their own things, right? You tell them not to do something, they still do it, right? So a child will have its own properties and methods. So we'll call those new properties and methods, right? And then often there are things that child class will do, which is overriding the parent's way of doing things. Parent objects, parent classes may have seen that already, right? In physical world, I mean, we see that, parent may have a way of doing something, and the child will say, no, I'll have my own way, right? You like to breathe at 70 breaths per second. I like to breathe at 68. So I'll override your functionality, right? I don't like your way, I'll do it my way. That's called override. So this is a word that you really need to get to know, because this becomes the basis of polymorphism. Now yes, we have borrowed polymorphism from biology. Darwin, right? And what did Darwin say about polymorphism?
Mutation.
Hmm?
Mutation.
Mutations. But I decided a long time ago I'm not going to study much on biology, so I'm going to not go to mutations. But what is the essence of mutations?
Variation.
In general terms.
Variation.
Huh?
Variation.
Variation. Variation. Variation on what?
Objects.
Right. So let's take, I guess, variation on object. So what makes that polymorphic? Why is that polymorphism?
In regards to biology, or?
In regards to general polymorphism world.
Oh, I only know it from like the biology sense, but
Okay.
Polymorphism in biology is like the idea that you can have like two animals, and then one of them is slightly divergent from the other one, and it's has different characteristics slightly, and that's kind of like in computer science polymorphism, where it's like you can have the same class, but then you can have two slightly different objects because of a different kind of structure or different.
I still didn't quite get two animals with different characteristics. How did that become polymorphism?
So if you have say a bird and a human, a bird, the way a bird would move would say it would fly, whereas the move function for a human would just to walk.
Is that biology or computer science? He gave me one example to cover both patterns, right? Both biology as well as computer science. So let's stick to biology. We have bird and human, and they move. And different ways of moving. The bird moves with two legs, the human also moves with two legs. What's the difference? The size of the legs, right? Is that a mutation though? Is that a mutation? No. But it is polymorphism. Would you agree? We can just let it go. It's not gonna work. I'll use your video again if you don't mind. Because I'm kind of deep in the topic now. Right? It is polymorphism though. So what is polymorphism then, if you were to explain it? So the word move is used, right? It's one word and different meanings. That's polymorphism. It doesn't just happen in biology. Now that's where it came. That's where the word polymorphism was born. Because Darwin explained this theory through observation in the animal kingdom or plant kingdom. He studied. He's a researcher, he studied. This is what I'm talking about. People understand patterns and apply it elsewhere to find new things. All we are doing is cheating here. We found polymorphism in biology, we are applying it in computer science. Oh, we have polymorphism. Now we want to apply polymorphism in physics. Oh, we come up with new things, right? So what happens is these associations of one application of one pattern in another, right, basically makes the human race better. Because that's what we call innovation. I call it copy and paste. No? Okay, so the computer science definition is also this. One word, different meaning. Now, how do we come up with that in Java or C++? Because you guys are also going to be programming in C++. Depending on what your employer wants, you're just programming that language, right? So how does polymorphism get enabled? It's enabled with overriding. So overriding is a concept. Overriding is a concept which means one word for a method and many forms defined in each class. So imagine you have the move method in the bird class. and you have the move method in the human class. Each one will have its own definition, different definition, right? But each one will have the same function signature. Same function signature. You guys understand function signature, right? The first line. Okay, if you guys give me that look, then I don't know if you know what a signature is. It's not what you, when you sign your offer letter for making 7 figures. Signature is public void move string A1 int d. I don't know why we are passing all these parameters, but when we think of the signature, we only think of this part. So begin end is there, right? Just that part right there. The name of the function and the formal parameter. That signature has to be identical in all classes, including the parent class. Okay? So I'm going to spend time to cover how polymorphism is enabled. Right? We're going to go through the full story of inheritance, try and understand that. Then we will talk about overriding, see how that is implemented. Then we will start dealing with polymorphism. And I want you guys to see it in the code. So next time you're talking to to a biologist, you can say, okay, you know polymorphism, so do I. You have your way of implementation, that's your pattern. My pattern is this one. I copied and pasted what you know in code. Okay. So, since every book talks about animals, like there are no other objects in this world, I'm not going to talk about animals because you did. So I'll come up with a different example, right? So I'll use a table because I'm using a table. And sorry, I shouldn't be shouting here. Public class table, right? And the table, let's say, has height and it has weight, or it has length and breadth. So table will have a constructor. I guess I'm going to go in Eclipse and do this because it will be a lot easier. So new Java project called inheritance, and a new class called inheritance. Actually, this should have been table, right? So refactor, rename inheritance to table. So source constructor using fields, and default constructor. Everybody knows what a default constructor is and an overloaded constructor, right? And then magically we'll put in getter setter. Okay? This was why I wanted to use Eclipse, right? So now I'm going to write a method, public void calculate area. And this can return an integer, I guess. So I can say return length times breadth. Okay. I can also say that this is the shape of this table is a rectangle. You guys get this keyword? Right? Yes.
How come when you didn't have the string shape argument in your public table constructor, it didn't give you like a red error, it gave you a yellow error? Like it wouldn't have compiled and run, right?
Because shape is, when I say this dot shape equals shape, I'm referring to the instance variable.
Yeah, but if there's no shape argument, then it wouldn't really make sense to do that.
No,
anyway,
right.
so.
But it's not a syntax error because the shape variable is there for the instance and available, so therefore a
So
non-issue.
even if it's pointless, it'll still compile and run.
Yeah, yeah. That's why we need programmer skill, right? I mean, auto code generation has its limitation. Right. Okay, so we have calculate area, right? So now I want to create another table, but I'm also very lazy. I don't want to create all these properties. So I think I want to deal with this table that's circular. So I'll create a class called circular table that extends table. So yeah, I'll get. So if I put a main in this, and I go make a circular table. So dining table is a good circular table, right? So I can say d table dot set. I don't have a set shape method. I don't have access to that property in the child class because I didn't give. And if I say dot shape, oh look at that! I do have direct access. You see that? D table dot shape is equal to circle, and it works. How come? Is table, that's why. They aren't private, I'm not encapsulating. Like table has nothing to hide. That's wrong, table should have things to hide. So we're gonna make it private and private and private. That's our rule now, right? And now that's cool. It's not visible. Okay? Now we are encapsulated. Yes?
What does the extends do?
Extends gives me access to all the contents of the table class in circle table instance. So I can say table dot set length. let's say if the radius of the table is 30 inches, right? That's a pretty good size table now. Okay, maybe 36, 3 feet. It's a 6 foot wide table, right? So now I'm going to use length as radius as well, if I want it, right? So let me go ahead and rewrite the CalculateArea method. And I am overriding that method. And I'm going to say what? Pi r square, is that what it is? So we'll say 3.14. I'm sorry? No, it's the radius. 6 foot diameter. 3 feet radius. Is that too big? I have a big table, what can I say? So we'll say this dot get length times this dot get length. And why does he have a problem? Cannot convert double to an int. Oh. Alright, well, I'm not going to change my signature. So there, are you happy now? Oh, he has a new problem.
You have to convert those to int. Or no, you already did it.
Okay, how many, what? The method getLength is unidentified for the type circle table.
Can I go back to the table? Maybe it's
Huh?
maybe the getter at table has something wrong.
No.
This is current object, right?
Mm.
So give me the length. One quick fix available, create method getLength. Yeah, right. So int radius is equal to this dot getLength. Semicolon. Return 3.4 radius times radius and 3.4.
I think there's a missing close bracket.
Okay, so do the multiplication, cast it and return.
Wouldn't it be better to use math.pi rather than 3.14?
There's still an error with the getLength though. Oh, because did we never assign a length through the constructor for table? Table doesn't have an initial length, right? Never initialized the length
I
for the
did.
private. Oh, yeah. But there's an error for that too, so.
I know. So extends doesn't work. Is that a big fat lie? It's in the same package also.
What is the error saying with the line 10?
The method SetLength int is undefined for the type circle table. So we are in circle table. And table has set length within. And it's also public.
Well, there's, can we check if, the G table object has access to any of the other methods?
Yeah, that's how I typed this, right? I said D table dot, right?
Mm-hmm.
And it says set length right there, right?
Yeah.
That's how I typed, right? So the compiler is showing it, and now I want to set the length, and I am typing an integer.
Oh, wait, but then I think it's because you have to go to CalculateArea, run that method, because CalculateArea is never getting called in the main method over here,
No,
right?
that's okay. So the problem is it comes back.
Yeah.
So there is something wrong in my project setup. When something like this that is somewhat irrational shows up, then it means something is wrong with my project setup, right? So let me save it all, right? And the problem goes away.
What?
What the heck happened here? So there are two separate things happening when in the compiler, right? It's kind of fun to demo this though, right? One thing is, as you're typing the code, the data dictionary of your class is building. So when you are using the name of the instance, it brings up the latest view of the class, right? When it's time to run, it would have run fine. I mean, if I hit play button, and it will, what it does at that time is it saves all the files, and then at that time the JVM will have access to the latest files. It will create a new .class file and use. So what was happening was, I would use dtable.setLength, it would work, and then if the change is not saved, right? At that point, it's ready to use the JVM to execute the code, right? It says, compiler error. But the moment I save things, we're fine. Uh-huh. Oh yes. And you can check out the timestamps. Okay. The thing is that since we are in Eclipse, all of that is happening in the background, and we don't get to see, underneath the hood. So maybe we should go and work in command line and look at timestamps of class files so we can get to know this a little bit better, right? So one day we will do that. But for now, I have the CalculateArea method, and this method has been completely overridden, as you can see. Yes? Parent is saying length, time, breadth. Child is saying pi r square. I'm sorry, I was not ignoring your comment earlier about using functions in math class. That's also a better way to do it, sure. But I just wanted something different, right? I'm not looking at the exactness of the output. You guys should, because you are the programmers. I'm just talking about polymorphism. Why do I care about if pi r square is right or not? You guys will do that, right? So now, when I say system.out.println, oh, I'm sorry, printf, right? Area for dining table is equal to what? %d?
Is an integer, right?
And then we say what? dtable dot calculator. And if I wanted to use the okay, let me not go there yet. That's pi r square, people. 36 times 36 times 3.14. That seems like a very small value, right? Is it okay?
Yeah, that's good.
You guys can do that in your head. I envy you. That's cool. My dad bought me a calculator when I was in the 7th grade, so things kind of went south after that. Okay. Yes, we had calculator in those days. I still remember the Texas Instrument scientific calculator for drawing the graphs. It was a programmable calculator. 1988, 1986.
Still
like a monopoly on
Yeah,
that.
we still use it. 64 KB of RAM.
Yes,
$130.
I still have it. We'll plug in sine, and all the full equation, and boom, the graph is there. Didn't even have to do it manually. It was a good cheating tool. Okay, so let's make a regular table. This is the boring table, right? And we're gonna use the length and width and height.
There's also shape, right?
This is the oddly shaped table.
There's also a shape argument, right?
Oh yeah, right. So that'll be odd. And boring table will have calculate area. Actually, let me just copy and paste that. So boring table will have area of B table or boring table. I guess we need our slash n's here, don't we? Are you all really good with printf now? Yeah? You guys should come in my 36A class and give them some hope. Because they're saying, you know, printf is so hard. And I said, it'll be like, you'll know it in your sleep by the time you get to the end of the quarter. They don't believe me. So maybe you guys should come in at around 5 o'clock. I teach that class before this class from 3:30 to 5:20. And just come and give them some hope. But don't worry about it. Because you have experienced it, right? They don't believe me. They say, well, everything is easy for you, so. I'm like, no, it's not. I just rely on patterns. Okay. So, can the boring table become the D table? I guess it can. Boring table just became the dining table, right? And area of boring table, that is now acting as dining table, right? You see that? So, oh, not D table, right? It should be boring table. Because now I did this assignment, right? And using boring table I call, so what do you think this next line will print?
4069.
4069 or 1200? Oh, my slash n. What do you think? Polymorphism?
So you basically changed the.
What?
So what you did was change the properties of the boring table into the dining table.
Yeah. No, actually I didn't do that. I'll draw you a picture because then so I had a dining table that was of type, that is the type circle table. And then I created a boring table which is a table, regular table. So when I said first time around with this call, boring table.calculate, actually we need the yeah, there we go. Now we can see. So, okay, that's better. So, when I had created the dining table, D table, that was this guy. That's of type circle table. And I set the length to 36 and then I did a print out and it printed 4069 and life was good. Yes? Next time I said, let me make a boring table with 20, 30, 40 and it's the odd table. And when I called boring table dot calculate area, sorry, words are overlapping, it printed 1200. So far so good? So then I said boring table is equal to dining table, which basically means I don't like my table, right? I want to go point to this table. I change the reference. Yes? So now I say area for boring table that is now acting as dining table, meaning boring table is pointing to the circular table, the dining table. And so now when we say boring table dot calculate area, which you can't see, but for purposes of the picture, what was it? Calculate area. It prints 4069. Yes.
What is the odd? What is odd?
It's just interesting. Odd is the property of the parent class, right? So odd is the shape. And I was saying, okay, this is an odd shape. As you can see, it's not even a rectangle. Just trying to be funny. Yes?
Right, so after you said boring table is equal to D table, are they basically the exact same thing?
Yes.
Okay.
Boring table and dining table, boring table and D table are pointing to the same object. Mhm. So instead of calling, when we called the calculate area method, it called the calculate area of this. The one thing that I don't know if you guys recognize, this is an object of type child. This is an object of type parent. This is a reference of type child. This is a reference of type parent. And parent is so powerful, right? As parent should be. It can point to its own type or to its child type.
Can it be done vice versa?
No, child is not as powerful. Child has to create its own children to do that. It has to become a parent. Laws of nature. In polymorphism. For polymorphism. I'm not talking philosophy in general, okay? I'm not in a position to. I can only talk about object-oriented programming implementation in Java and C++. Yes?
So dynamic people cannot change its properties to the following table.
Okay, yeah. Now there is a follow-up question. Well, how powerful is really the parent, right? So let me put this out here. Parent is powerful. Can point to object of type parent. Right? B can point to object of type child. Now the question is, what can parent access? In child object. And this will take a little while for light bulbs to come on. So parent can access overridden methods only. And I'll prove this beyond a reasonable doubt on Monday. Or maybe I could prove it now. It's not hard. No, yeah, right. So if a child has its own properties and new methods, parent is like, you can't access it. So parent tries to be powerful, but can only be so much powerful. So parent can only access the properties and method it provides. You know, child, here you go. These are my properties and methods that you can use, right? So child can use, a parent reference can access those. But you also saw when I say boring table dot this boring table dot calculate area, it called the calculate area of the child. So very important concept. Yes.
Let's say I create a class and just call it A and add some getter and setter methods. Then I create a child of A and I just call it B. And then I create a child of B and call it C. C does not have access to any of the getter and setter methods of A, right?
If they are public, it does.
Oh, it doesn't just have its own parent, it has the parent's parent.
Oh no,
also.
yeah, you can go to grandchild.
Oh.
That's why kids like grandchildren, because they're more liberal, right? Give more gifts. Parents have more methods and control. Grandparents don't.
So there's a huge link of parent and child, the last child has all the methods of all the previous parents.
That's why inheritance is useful, because the child is the beneficiary of all the properties and methods in the parent classes. But they're not, let's take that on, I mean, as a discussion, right, at some point, but let me, because since we have to kind of wrap up for today, I'll paste these as your notes and then also capture what's on the whiteboard. So we can say that parent is powerful in that it can access properties and methods that it provides, and 2, overridden methods. Okay? That is the key point. And the fact that it can access the overridden methods, this is the enabler of polymorphism. Are you guys familiar with array of objects?
Yes.
Yeah.
Array of stores?
Yes.
Okay. See if you can finish your, you will be done with lab 3 by Monday, right? See if you can finish it. Because then once you have worked with array of objects and you have realized what it is, you come back in Monday, and when I explain polymorphism, the light bulb will come on very quickly. Just know array of objects. If you're not completely done with the lab 3, just write at least 1 or 2 functions, like compute the average of the stores and just print them out. At least 1 function. Come on, you can finish 1. Unless you're the type of person that starts doing the lab the night before it's due. Then guilty. I mean, okay, I do that too, by the way. I prepare my lecture the hour before it's due. Oh, that's okay. I'm not afraid. You can do that after 20 years of Java. You better be able to, otherwise you're really pathetic in teaching. Right? Great, that's recorded too. Yes?
Did we want to make one business method that calculates, like that has an array with all the different calculations within it? Or do we want to separate that into different business methods for that lab 3?
I think different ones, right?
That made more sense to me, but for some reason I got the idea that it was supposed to be one.
She's talking about lab 3, and so.
You have the data already, you have the data for week, you have the data for, like.
So do it all in one?
Yeah, I just reused them, why would I want to go ahead and calculate over and over again?
Not over and over, but what if I wanted only 1 and not all 6?
Then you get it,
I just get all 6.
but you asked for all 6.
I did in this case, yeah.
Yeah.
But what if I only want 1? Then I have to call you back, I have to hire you back, I have to pay you to write another method.
Then you have to change the specification too, right?
I said print all 6, but if you want to work yourself out of a job from a design perspective, separate them out so I don't have to call you back, even though I didn't ask for it.
I thought-
See, I made a good
Doing
case
the
now,
work.
didn't I?
Yeah, I thought it was doing the work, why bother? So-
No, you're right. But here, this very question is a very good question. You can write one nested for loop, do all the calculations and be done, right? So now you are a designer and you're making a decision. Are you a designer that is saying, I'll do what the customer wants and be done? Or I'm going to do such a good job of design that they don't have to call me back again. Right? So what kind of a designer do you want to be? One that works yourself out of a job, or one that codes and writes so they keep calling you back? See, that's the question. Now, when you make a decision to work yourself out of a job, you're in fact out of a job, because there's nothing more to do. But when you are a designer like that, you don't remain a developer for the rest of your life. What happens is, somebody will recognize that design pattern about you as your skill and say, this is a good designer. We must keep this person because they do a good design. And hence the latter, right? Always, at least in this course, it doesn't cost you anything to work yourself out of a job, because you will be out of a job by the time you're done with this course. Who cares? Maybe this is the only opportunity you have to design to work yourself out of a job. Because in the future you may need to. Are you guys getting my joke?
Yes.
Okay. Like, man, that's not a joke. You guys are so serious. So. Now, these are traits of good engineers. Good engineering is designing for the future. And this is the hardest thing I have to sell to you guys. Why should I work extra? Why should I do this now when I don't need it, right? Even in the advanced Java class, people would say the same thing to me. Why are we writing all these methods when you're not going to use them? I said we will in the future. Oh, but what if we don't? Then I'll write it then. We kind of go back and forth. I'll see you guys on Monday. Enjoy your weekend.